Section: Introduction. In this section, we will discuss web automation, which involves automating tasks on websites without human intervention. This automation saves time and improves efficiency. Traditional methods use wrappers to extract data from specific websites, limiting adaptability to new or changed website structures. Rule-based and auto wrappers both rely on manual examples for each website. Large language models, LLMs, have enhanced web automation by enabling agents to navigate and interact with web content independently. However, current web agent frameworks have low success rates on open-world tasks and struggle with reusability. Our work introduces a crawler generation task to automatically extract information from web pages. This task aims to generate rules or action sequences for extracting target information efficiently across different websites. Our framework, AUTOCRAWLER, uses LLMs to progressively understand HTML structures and generate executable action sequences. Experimental results show the effectiveness of our framework in generating web crawlers. Section Summary. In this section, we define the crawler generation task and discuss the dataset collection process and evaluation metrics. We formulate the task as generating executable rules to extract target information from web pages on the same website about a specific entity and its predefined attribute. We utilize the SWDE dataset, which includes web pages and labels from 80 websites in 8 domains, to test our crawler generation task. Section: Extended SWDE. In this section, we extended the SWDE dataset by manually annotating 21 sites in 3 domains. The original SWDE dataset had an average of 4,480 triples for 3 predicates per site, while the extended dataset had 41K triples for 36 predicates per site. We worked with DS1, which includes 166 annotated web pages from 30 real-life large-scale websites in categories like books, shopping, hotels, and movies. To prepare the dataset, we created instructions for each domain and attribute as input for LLMs. We then selected 100 web pages from each website in each domain as the test set. We pre-processed the websites by removing unnecessary elements like less than script greater than and less than style greater than tags, keeping only the @class attribute. We also standardized the annotations for consistency with the web content. This resulted in 3 datasets with a total of 61,566 web pages covering various extraction tasks across 10 domains. When evaluating the LLMs, we focused on their ability to extract information from web pages and generate action sequences. Traditional evaluation metrics like precision, recall, and F1 score were used, but we transformed the evaluation into an executable form. We categorized the executability of action sequences into 6 situations based on precision, recall, and F1 score results for each extraction task. We calculated the success rate based on the proportion of correct results in our task. In the AUTOCRAWLER framework, we outlined a 2-phase approach for generating a crawler to extract specific information from semi-structured HTML. We first used a progressive generation framework that leverages the hierarchical structure of web pages, followed by a synthesis framework based on results from multiple web pages. Instead of using XPath, we treated the crawler generation task as an action sequence generation task. This involved generating a sequence of XPath expressions from seed web pages to prune irrelevant page components and extract the desired element value. To handle the complex and hierarchical structure of web pages, we implemented a progressive generation strategy involving top-down and step-back operations. Top-down operations refine the DOM tree down to the target node, while step-back operations adjust selection criteria by moving up the DOM tree for more accurate XPath targeting. This iterative process ensures the generated crawler is complete and executable. Section Summary. In this section, we present the AUTOCRAWLER framework for generating crawlers to extract specific information from semi-structured HTML. Our approach involves a progressive generation framework that leverages the hierarchical structure of web pages and a synthesis framework based on results from multiple web pages. Unlike traditional methods that use XPath, we model the crawler generation task as an action sequence generation task, aiming to generate executable crawlers efficiently by pruning irrelevant page components and extracting the desired information accurately. Section: Synthesis. In this section, we obtain an executable sequence of actions during the generation process. However, there are variations in where the target information is located and the structure of different web pages. The action sequence may be too specific to a single HTML, making it less adaptable. To improve the reusability of the action sequence, we suggest a synthesis phase. We randomly pick n_s web pages from the test case as initial web pages. Then, we create an action sequence for each of them. Next, we run multiple different action sequences on the initial web pages to extract information. We gather all the action sequences and their results and select one that can extract all the target information as the final action sequence. To test AUTOCRAWLER practically, we explore how it compares to baseline methods like GPT 3.5 Turbo, Gemini Pro, GPT-4, Mistral 7b Instruct v0.2, CODELLAMA 34b Instruct, Mixtral 8x7b Instruct v0.1, and DeepSeek Coder 33b Instruct. We also use ZS_COT and Reflection as baselines. Since LLMs have limited context, we conduct all experiments in a zero-shot setting. We test them on SWDE, Extend SWDE, and DS1 datasets. We set n_s equals 3 and max retry times d_max equals 5. In addition to the evaluation metrics mentioned earlier, we also use precision, recall, and macro F1 to assess the quality of different action sequences comprehensively. Our results on SWDE demonstrate that all models show improvement. Incorrect or missing extractions can significantly impact executability. To showcase the effectiveness of our framework in generating executable action sequences, we compare COT, Reflection, and our framework using the golden label of the instruction. By providing the same extraction targets, we can compare how different frameworks generate action sequences. The length of the action sequence depends on the LLM's capability. We analyze how different LLMs affect the number of steps in AUTOCRAWLER. Stronger LLMs result in shorter action sequences. For instance, AUTOCRAWLER with GPT-4 generates 1.57 steps on average, while with Mistral 7b, it generates 3.82 steps on average. This indicates that more powerful models better understand the web page structure, leading to more accurate XPaths and shorter sequences. We define the compression ratio of length and height as the ratio of the original web page's length, height to that after being pruned by AUTOCRAWLER. We rank LLMs based on their performance in compressing length and height. A U-curve is observed in both ratios, suggesting that powerful models can generate correct XPaths without needing to backtrack, while weaker models struggle to understand the web page structure, resulting in less reliable XPaths. Section Summary. In this section, we propose a synthesis phase to enhance the reusability of action sequences in web scraping. By randomly selecting seed web pages and generating action sequences for each, we aim to find a final action sequence that can extract all target information across different web pages. Our experiments compare AUTOCRAWLER with various LLMs and show that stronger LLMs result in shorter action sequences, indicating a better understanding of web page structures and more accurate XPath generation. Section: XPath fragility within AUTOCRAWLER. In this section, we discuss the fragility of XPath within AUTOCRAWLER. XPath fragility refers to the issue where XPath expressions may not work correctly on new web pages. This happens because XPath is very specific in defining elements using predicates like text or at class. We are particularly interested in the fragility related to text, as the web pages we deal with are from the same websites where at class is a reliable characteristic for creating consistent action sequences. We have identified XPath expressions that heavily rely on text and aim to investigate how reusable they are based on text features. By manually analyzing bad cases using two types of predicates, contains and equal, we found that the more powerful the LLMs are, the fewer bad cases occur with AUTOCRAWLER. However, even with state-of-the-art LLMs like GPT-4, there are still issues with XPath fragility, indicating that solely depending on LLMs to generate dependable XPath still needs improvement. Moving on to error analysis, we looked at the recorded action sequences of AUTOCRAWLER with GPT-4 and identified common failure modes such as unexecutable actions, overestimations, and other issues. One challenge we encountered is the lack of generalizability in AUTOCRAWLER due to variations in target information and web page structures across different web pages within the same website. For example, extracting the company name from job listings on a website like Job Career Builder can be tricky when one web page lists the company name differently. Another difficulty arises when dealing with multi-valued information extraction tasks, like extracting addresses from restaurant web pages or contact phone numbers from university websites. While AUTOCRAWLER can generate action sequences to extract parts of the information, creating a comprehensive sequence that captures all the necessary details remains a hurdle. In the realm of web automation with LLMs, many studies explore open-world scenarios in web simulation environments, covering tasks from online shopping to software development. Current web automation frameworks focus on optimizing web interactions but lack reusability, often relying heavily on LLMs even for similar tasks, leading to inefficiencies. DOM-based web extraction methods leverage the hierarchical structure of web pages, including rule-based approaches and learning wrappers that extract content. These strategies use distant supervision to create training samples by matching data from knowledge bases with web sources, reducing annotation efforts but potentially resulting in false negatives due to incomplete knowledge bases.